Shut up.
This is period 3, Thursday, October 25th, Out of This World project. All right, so don't worry about all this stuff. Okay, all that stuff there is the legal description of what I'm supposed to teach you. Nobody cares, okay?
Yes.
Starting down here, this is the part you care about. Part 1. Complete the chart below. On each planet, you will assume that the rocket is being launched from the surface of the planet. The initial height is 0, and that the initial velocity of the ball is 160 feet per second. However, the acceleration due to gravity near the surface of each planet is different. And then it gives you 3 different planets: Polynomia, Algebrainum, Quadraticus. Okay? And for each of those, they have a different acceleration due to gravity. Okay? All of this stuff here about the 160 you don't have to worry about because it's already given in the equation. Okay? So all you have to do to fill out this table on page 1 is take half of g. So for Polynomia, g is 20. What's half of 20?
10.
That goes there. I am not going to do the other 2 planets for you. You have to figure them out by yourselves. I know that that's very difficult. You're going to take this number for half of g and then put it into this equation. And now that you have done that, now you have the quadratic equation for the flight of that rocket ship. Okay? This problem is very similar to the kangaroo problem. In the kangaroo problem, you were given an equation that models the kangaroo hop. Here, we're given an equation that models the path of the flight of the rocket ship. And all of the calculations are really going to be done the same way as the kangaroo problem. All right, so on my, let me just flip over to the other page so you know what it is I'm trying to do. And I'll read that to you too. So for part 2, show all work to complete the chart below for the 3 planets. For each planet, you will calculate the time required to reach the maximum height reached, and the time required to return to the planet's surface. Do all your calculations on a separate sheet of paper for each planet. All calculations should be neat, labeled, and answers circled. Okay, so I'm going over to my blank piece of paper to do my calculations, and I am doing all of the work for Polynomia for you. So I'm labeling this Polynomia. Polynomia. There we go. Polynomia. I did something wrong? Nomia. There we go. I knew something was wrong. Alright, so I'm doing all the calculations for Polynomia for you. You are then going to use that example to finish Algebrainum and Quadraticus. Okay? So let me just sketch this for you. Okay? Oh, where's my equation? I need my equation. My equation I'm getting from, again, page 1. Let me just copy this down. So my equation is h of t equals negative 10t squared plus 160t. That's what I'm working with right now. That's the equation for the rocket ship on Polynomia. All right, and then on my horizontal axis, we've got time in seconds. Okay, that's what t is standing for in this equation. And then on the vertical axis, we've got height in feet. All right, so h stands for height, t stands for time. All right, and then the problem is telling you that we're starting when time equals 0 at 0 feet. In other words, at the beginning of this equation, we're starting on the ground. And then this is this a concave up or concave down parabola?
Concave down.
Concave down. So it's going to fly up in the air. It's a concave down parabola. It's going to land back down on the ground. So when they are asking in our table for the maximum height, what point are we looking for on this graph?
The highest point.
No, not -10. What did you say, Axel?
The highest point.
The highest point. Do you have a algebraic word to describe that highest point?
The maximum.
Maximum is good. Vertex is good. Very good. I'm sorry. Vertex, yep. All right. So this is in standard form. We're going to use the formula for finding the vertex in standard form. What's the value of A? -10. What's the value of B? 160. What's the value of C? 0. Good. And the formula for the vertex is T equals -B over 2A. So I'm going to plug in -160 over 2 times -10. And then I'm just going to do some calculations here. So I have -160 divided by, now the denominator has to be in parentheses if you're going to do this all in one shot, okay? 2 times -10. I saw a lot of people making a mistake. I put 0.10, yeah. I saw a lot of people making a mistake and not using parentheses to show that the denominator gets calculated first. That's an 8, by the way. So this gives me T equals 8. So that's 8 seconds. Yes?
So you got -10 squared, and then that's another T before the 160?
-10 squared plus 160T. And I got that equation from the front page. All right, so now we know the T coordinate of that vertex. Okay, we're going to plug that in to the original equation to find the H coordinate. So I've got H of 8 equals -10 times 8 squared plus 160 times 8. So that's going to give us the height. All right, so I've got -10 times 8 squared plus 160 times 8 gives me 640. So the height, that's the maximum height. The height is 640 feet. All right, so the vertex is at 8, 640. All right, as I told you before, at T equals 0, the height was 0. All right, and I want to make sure that you are going to graph the entire flight of the rocket ship. That means you have to start when the rocket ship takes off and finish where the rocket ship lands. So I need the coordinates of this point over here also. All right. Remember the kangaroo problem. You're going to find the coordinates of that point just like the kangaroo problem. Anybody want to take a guess as to what the coordinates of this other point are where the rocket ship lands on the ground? What's the coordinates of this point right here? How far is the length of that path? 16. Excellent. Giancarlo, if you are recording me, I promise you I'm going to put this video up on Google Classroom, so you need not do that. Okay, how did I find that this is 16? Anybody remember?
It's half.
It's right. So in order to get to the vertex, it's exactly halfway because these are symmetric points across that, or these are reflections across that axis of symmetry. Okay? All right, so we're going to use all of those numbers now in our table. Okay? What is the time required to reach the maximum height?
8 seconds.
8 seconds. What was the maximum height reached? 640 feet. Good. And what was the time required to get back to the ground? 16 seconds. Good. All right, now we have to graph that on the graph paper, okay? Now I've done some work to try and figure out how are we going to be able to fit all 3 of these planets on the graph paper, and I've come up with some suggestions about how to label your axes, okay? So first of all, I'm holding it in portrait form, not in landscape, okay? I'm labeling this Out of This World. That's the name of the project. The horizontal axis is time in seconds, as we discussed previously. Time in seconds. And then I think we can use each block is worth 1 second. So we're just counting 1, 2, 3, 4, etc. Okay. And then this rocket ship lands after 16 seconds, so we only have to go to 16. Bless you. As far as the height goes, I think the best way to do this is to label them each worth 20 feet. All right, this is height in feet. And let's make each block worth 20. So we're starting with the first block at 20, counting by 20s, 20, 40, 60, 80. And we have to go all the way up to 640 to graph the vertex. All right, so I'm going to come up with 5 points in the table to graph the flight path on Polynomia. And these are, most of those, actually 3 of the 5 points that I need are already here in my calculations. So I'm making a table of time and height. My vertex is at 8, 640. And my 2 t-intercepts are at 0, 0 and 16, 0. So I've got 3 of the points I need. So I need 2 more points, and I don't want them to be too close to the vertex. I want to be able to spread out and see some more accurate data over the entire flight path. So what I'm going to do is I'm going to go halfway between 0 and the vertex. So what's numbers halfway between 0 and 8? 4. So I'm going to find out what's my height at 4 seconds. And I'm just doing this in my y equals screen like we've done all of our problems. Okay? And then I'm going to the table. Alright? I'm just going to take a few seconds to verify the points I already have. So I've got, you guys can see this? There we go. Can you see that better? So I've got my 8, 640. Yep, that's checking out. Alright, I'm going to check my 0, 0. Yep, alright, so I'm doing good so far. So let's take a look now to see 4. Looks like 4 has a height of 480. And let's find another 480 in my table. There we go. 12, 480. Sorry you guys can't see that very well, but there it is. 12, 480. Now I have my 5 points.